Never go wrong with a good smile. Remember in week 1 I said, try to have fun. Let's have fun. All right, chapter 11. Let's move in your. All right, so that puts you at page 345 in your text. Chapter 11, we're going to talk about compound interest rate and the time value of money. All right, now when I talk about what you might expect to use in your professional careers going forward, listen up, and it's going to involve this chapter. If there's anything that I use in my professional trade every day, it's this chapter. It's folks coming to me and saying, how much money do I need to retire? If I give you $100 a month, starting now, what can I assume to have at my retirement? Okay, should I borrow money? Should I pay the upfront cost, or should I borrow money? So you might find yourselves in your personal life using those same type of questions. You'll also find yourself in a business setting of when you are trying to do something that every CFO will oversee and say, we want to maximize cash flow. Now, a lot of times we looked at the payment terms in our discussions. Several of you hinted on using, not going ahead and paying it up front and getting a 1%. I think we used a 1% example, but a lot of you mentioned not accepting that discount because you could earn a greater return on 1%. Okay, again, maximizing cash flow. That's an example of it. So easily we can see where a lot of these principles are going to play in both our personal and professional life. Okay, so let's outline some of our objectives here. We are going to manually calculate compounded interest rates. We're going to compute compounded amounts and compounded interest by using interest tables. I'll show you where to refer to those. We are going to calculate an annual percentage yield. If you've ever purchased or financed a car, you see it quoted as APY. We are going to calculate the present value of a future amount by using the present value table. We are going to jump right in. All right, so compounded interest. I'm going to assume that you went ahead and looked at compound interest and the time value of money. But compound interest, interest that is applied a number of times during the term of a loan or investment. Remember, under the simple method, we just assumed it was charged one time. Now we're going to charge it multiple times against the loan. The time value of money, the idea that money now or in the present is more desirable than the same amount of money in the future because it can be invested and earned interest as time goes by. All right, if you want to look at the time value of money, go back and look at the fluctuations of a postage stamp. And the idea is a dollar probably will not have the same purchasing value 20 years in the future as it does today. All right, compound amount or future value. We will abbreviate that with FV. Present value, we will abbreviate with PV. The future value, the total amount of principal and accumulated interest at the end of a loan. Present value, an amount of money that must be deposited today using compound interest to provide a lump sum of money at some point in the future. All right, I want you to flip over to Exhibit 11.1. You're going to see a nice little chart that is going to show the influence of the time value of money. And you'll see in this that the value of $1,000 invested at 10% annual interest. Now we're going to see the difference that future amount will be when we compound that interest rate versus using a simple interest rate. So we can see if we're making the investment, the more times we compound it, the higher our future value will be. Now again, if you're on the borrowing end, you might want to look at how, if you're using a compounding method, you want to look at how many times we're compounding. All right, action alert. This is when you think about payday loans. And you see payday loans, you see it quoted where folks are earning triple digits. This is how they're earning triple digits. Your average payday loan compounds every 7 or 14 days. If you ever think of taking a payday loan out, call me. All right, so to manually calculate compound interest, we're going to use the simple interest formula, which is what?
PRT.
Let's go all the way back to the last one. Simple interest formula is equal to what? Principal times rate. All right, each time the interest is calculated, it is then added to the principal to determine the new principal. So compound interest is going to be equal to what?
Compound amount minus the principal.
Compound amount minus the principal. Okay, so if you flip over to, again, the table on page 348, so table 11.1, you're going to see a compound interest chart, or table. You're going to see what factor up at the upper right header, you're going to see compounding at various interest rates. What we want to do. So the compound amount of the future value. So we're going to say the compound amount of the future value is equal to what? We can say the table factor that you find there multiplied by what?
Principal.
Times principal. Compounding periods, I'm not introducing anything new. Refer to the simple interest video. And interest rate per period. So interest rate per period is equal to what?
Nominal rate over periods per year.
Periods per year. All right, now we keep flipping over. Once you refer to your text, and you're going to find back at table 11.1, what you're seeing here is the future value of $1. Compound periods per year. If we say it's compounded annually, how many times?
12.
Once. Semi-annually. Twice or every 6 months.
I don't think it's 12 months in a year.
Quarterly. Every 3 months. Monthly, every month. Daily, every day. You see it continuously We're gonna say it's infinite. All right, let's look at the steps for compound interest tables. All right, remember, just scan across the top row to find your interest rate per period. Look down the column to the row corresponding to the number of periods. The factor at the intersection of the rate per period column and number of periods row is the future value at $1 at whatever compound interest rate you're using. So, for instance, $1 compounded at 8% for 12 periods is worth what?
$2.51.
2.51.
817.
Okay, now let's keep flipping. And we're going to say using compound interest, I'm going to show you an example. All right, so all right, let's flip over to page 349. Steps for using compound. I'll flip the page, I'm sorry. Over to page 350. Steps for calculating new compound interest table factors. All right, so let's just say that you're going to find a value that's not represented in the table. Usually if you were dealing with a half or some other increment that was not quoted at the top, how are we going to solve for it?
Find the two table factors that represent half.
Find the table factor that represents half or values as close to half as possible. Multiply two table factors to form the new factor and round the new factor out to 5 decimal places. All right, let's look at an example. Calculate a new table factor and find the compound amount, $3,500. Invested at 16%, compounded quarterly, $3,500. And we're going to compound quarterly at an interest rate of 16%. So we'll do it quarterly for 7 years at 16%. All right, step 1. You're going to want to find what's the interest rate per period. $16% per period. So quarterly by 4. So what's my interest rate per period? 4%, or 16 divided by 4. Now, how many compounding periods am I going to have?
With quarterly, it'd be what, 4?
Well, we solved that for here. So for each period, we're going to be receiving or paying 4% per period. But I'm going to do this for 7 years. So I'm going to have 28 compounding periods. So every quarter I'm going to compound. So quarterly for 7 years, I will have 28 compounding periods. So now, what is $3,500 compounded at 16% for 28 compounding periods? With your table, we can go to 28 periods.
No. 25.
Okay, let's use it at 25 periods.
If you divide it in half, it would be 214.
Would be what?
214.
2/14. If we were going to use this example of 28 compounding periods, I was going to use the table, but we'll build on this. How would you solve it?
Well, going by this problem, where it says to cut it in half,
Why are they cutting it in half?
because it's the closest, because it's on the compounding table. So that's step 1.
Step
For
1.
the unknown that's on there, because it's not, 28 is not on there. So for the unknown, you cut it in half.
For the unknown, cut it in half. And now we do have 14% shown on our table. So what's 4% compounded at 14 periods?
Excuse me, thank you.
Um, 14 at 4 periods. Wait a minute, no, 4% at 14 periods. 1.731.
5 decimals.
1.73168.
So for 28 periods, where are we?
$3.46336. Did you just add them two together?
Yes. No, we multiply them together.
Oh, you multiply them. Oh, you do.
Should be around 3.
7, 3. Oh, I did multiply the first time.
What is it?
3.46336. Is that right? 73168.
I got it.
73168 times. Oh, wait a minute. I multiplied times 2. My bad. Yeah.
I got it.
1.73168 times 1.73. 2.99 what?
871.
871.
Yeah. Yes.
All right.
Yep.
Now we're going to take that compounding factor and multiply it by the principal. And what's my closing value?
3,500. 10,495.50.
So $3,500, let's just say if we invested it, earning 16%, compounded quarterly for 7 years, our future value would be $10,494.50.
I actually understand that.
All right, annual percentage yield. So remember, annual percentage, or annual or nominal rate first. Your nominal rate is going to be your stated rate, stated or advertised rate. Your annual percentage yield, again, here we see this effective rate. It's going to be the effective rate that you pay or earned. Let's assume we're investors. All right, Exhibit 11.4 is going to show you $100 at 12%, and it's varying compounding results annually, semi-annually, quarterly, and monthly. And again, observe, the more times you compound, the higher you're going to boost that future value. All right, so let's look at calculating annual percentage yield or effective interest rates. And let's say, what is what is the compound amount, compound interest, and annual percentage yield? So compound amount, this off right here. Compound amount, we're going to solve for compound interest. And the annual percentage yield. And I'm going to give you an example. $7,000 invested for 1 year. And let's give it a 6% interest rate. Compounded quarterly. Interest rate per period is what? One thing you're always going to have to adjust for is the time, or we'll just say the compounding frequency. So the interest rate per period is what?
1.5.
6% divided by 4 equals 1.5. Now, how many periods? All right, so we're at 1.5 now. How many compounding periods are we going to have? How many times are we going to compound that?
Well, 1 year. So I mean, 1.
1 year, but what's our compounding schedule?
4.
Yeah, 4 times.
So we're going to have 4 compounding periods. One year, 6% compounded quarter. So interest per period, 1.5%. And our compound periods are 4. All right, what's the compound amount?
compound amount, 7,000.
You're close. How are we gonna get the factor?
Your top.
Refer to your table. 1.5%. 1.5%. And how many periods are we compounding? Or 4. So what's my factor?
1.
So my compound amount is equal to 1 point, what was the factor?
0.6136.
1.06136. Multiplied by our principal amount. So what are we at?
7,429.52.
7,429.52. So that's our compound amount. Now the compound interest is what? How much compound interest are we paying?
Is it the 6?
$429.52. So our annual percentage yield is what? We're going to take the total compound interest in 1 year, and what are we told to divide it by? Let's look at our text. By the principal. So total compound interest in 1 year was $429.52. And the principal was $7,000. So our APY is
$429.52.
6.14%. So to illustrate this, your nominal rate is what? Your nominal rate or your advertised rate that you would probably see is 6%. But when they put these factors on it, a payback schedule such as this, you're actually paying 6.14%. Dig your credit card statements out. All right, so real quick, let's flip over and let's look at using a present value table. Review the steps for using the present value table. Refer to Exhibit 11.5. And you're going to see what I'm talking about when I say the present value. All right, so we're going to try to determine present value is unknown, but we know the maturity value and we know the interest rate. All right, using table 11.2. Find out how much money must be invested at 8%, compounded quarterly, to have $3 million 3 years from now. think about this. You've got a big purchase down the road and you're trying to save money. Who can start us off?
Professor, you gotta give us a minute. We're still trying to process all of that. Give us just like 2 minutes.
Sean's the one who wanted problems. We're running out of time, so I'm breaking these problems out.
Told you.
I've been doing this now, but I'm purposely doing more now for you. All right, so let's look at, this will be the last one we'll do. Using the present value formula. Find out how much has to be invested. At 8%, so interest is going to be 8%. Invested, all right, so we're going to have $3 million. So the future value is $3 million. And let's say that we are going to have 8% quarterly for 3 years. So in 3 years, we're going to have $3 million. How much do I have to invest now if I can earn 8% compounded quarterly? What is the present value? What must I put up in order to have $3 million? What's our interest rate per period? Two percent. All right. Compounding periods, how many do we have? Three years, and we're compounding quarterly, so we have 12 compounding periods. So present value is equal to what? Let's use that table. You know it's going to be some factor multiplied by 3 million.
$2.51817. 8%. All periods.
2% down to 12 periods. We have a factor of 0.7849.
Oh, 2%.
So 2,365,000. So $2,365,470
0.7849.
from the present value table.
The next page.
Present value table.
It's on 358.
Oh.
That's what lost me too.
2%.
There it goes.
Oh, I don't think we got that far yet.
Oh,
No. That's far.
7.7849. 78849. Got an extra 8 in there.
78849.
78849.
78849. Right.
All right. That's it. That completes. What we looked at is using, remember, we used those two tables. We used the compound interest table and the present value table. Most important thing is to solve for first, what are the interest per period? We factor in the compounding schedule. In order to do that, take the interest per period multiplied by the number of compound periods. In this case, on the board, you have 2% interest per period. We get that by 8% divided by the quarterly schedule form. Compound periods, 4 times a year for 3 years, 12 periods. Using the interest compound per period, you put the appropriate table and find the present value or find a future value. All right.
Oh, wow.